Okay, Bismillahirrahmanirrahim. Assalamualaikum and good morning. Okay, today we are looking into sequences. Sequences basically sequences is normally is look like as a set. Okay, and then it is basically is enumerated sequences collection which repetition are allowed. And in order matters lah. Okay, enumerated, and then it is uh, in order. Sorry, order lah. Yeah, for example, if we have the sequence negative 2, 4, negative 8, 16, and negative 22. In the set also we need to have the bracket. Yeah, the bracket. Okay, for the sequence, okay, let's say we have 1 0 1 1 0 1 0 1 is a binary. For the set, we represent as element, but the repetition only we have the element, the same element. Okay, this one is for the recap. Last 2 weeks, we have functions from A, we map to B, and then we have one-to-one function, and then we have bijection. Okay, and then we also have uh, subjective, and so on lah. Okay, this one is the recap for the last chapter. Okay, then we also have a look at composition of the function by function f and g denoted with f composed with g. Okay, like this, and then we have also take a look of the floor less than or equal to, and then ceiling is x is greater than or equal to lah. Okay, this one is a sequence. Sequence is represent the ordered list lah, of the element lah. And then sequence is being defined by a function from a subset. Okay, and then and to a set S, we can use the notation an to denote the image of the integer n, and then we can call an as the term of sequence. For example, if we have the subset of 1 as a set 1, we define set 2 as term set 2, and then we can find out a1 is 2, 4, 6. We have a sequence in order lah. And then for this one we can create the formula. Okay, n is equal to 1, a1, a2, a3, an equal to 2n lah. Because every time the term an is double lah, is 2n lah. Okay, and then sequence we use the notation, the bracket and to describe sequence. Okay, important do not confuse with the bracket element used in the set notation. It is very convenient to describe sequence with a formula. It is direct. Okay, this one is direct translation. For example, if we have a sequence of in the previous slide, we can see bracket a n terms which are an is equal to 2n. It is a map based on the formula. Okay, unlike a set, the same element can appear multiple times at different position in the sequence. Unlike a set, in order matters. Okay. And then this one is a formula game. You can see the pattern. Pattern that you can include. Okay, we have an equal to 2n minus 1. Okay, this one because we map two terms, and then we can come out with a formula. Okay, and then this one an is equal to minus 1 power of n. Okay, and then we get this kind of pattern. Same goes to number 3. If you look this one, an is equal to n power of 2 plus 1. And then you got 25, 2 power of 2, 4 plus 1 is 5. Okay, 2 power of 3 is 8. Uh, uh, no, 3 power of 2 is 9, plus 1 is 10, and so on. Lah. Okay, and then this one is the rule. If you have the rule like this, okay, from 1 until 10, and then it jumps. From n1 terms 3, can use the test rule to n. To n to multiply by 1, 2, 2 multiply by 2, 4, 2 multiply by 3, 6, and so on. And then this one is the terms. The x is the term, and the n is the term number. Okay, if you have x, for example, x10, okay, you can have 2n plus 1 is equivalent to 2 multiplied by 10. It's multiplying the terms number plus 1 is equivalent to 20 plus 1 is 21. Okay, this one is just terms. You can take a look. We have two terms here, and then we have the formula an 2n minus 1. Okay, you can replace the value is equivalent to. Okay, we have 1, 2, minus 1. And then you got 2 minus 1 is equivalent to 1. And so on. 5, 7, 9, and so on. Okay, and then another term is a string. We have a string. Finite sequence are also called a string, denoted by A1, A2, A3, and AN. And then the length of the string S is the number of terms that it consists of. Okay, we have the length that consists in the string. And then the empty string contains no terms at all. It has length of 0. Okay. Okay, and then we have a summation. Summation, basically for the summation is we sum up the terms. Okay, for example, here we have what does the summation mean? So we have summation of n is the upper limit, j equal to m is the lower limit, and then we have summation, and then we have multiplication. Okay. Multiplication aj, j equal to m and am, and it represents the sum of am lower limit, m increase m plus 1, okay, m plus 2 until the upper limit and okay, the variable j is called the index of the summation, the subscription that running from its lower limit m to its upper limit n lah. We could as well as use another letter to denote this index lah. This one is just the example for this one. Okay, and then we have summation sign, we have stopping upper limit, and then we have terms, or we can have a typical element. Okay, this one sometimes we call it as a typical element. Yeah, for example here, we have for some j equal to m, aj, and am is the lower limit. Okay, we multiply until the upper limit n lah. Okay, for example, if you have 6, j is 2, and then we have a typical element there, aj, and then we start from the lower limit, a2, a3 until a6, we combine this summation in total. Okay, for example, if you have E, let's say you have the terms I, the start from I equal to 1, okay, until 10. And then you sum all this 1, 2, 3 until 10. If you have the summation of I equal to 1, the upper limit is 100, you sum until 100. Same goes to the pi I. Okay. Okay, this one is the upper limit, and then this one is a formula of sequence, or sometimes you call it a typical element. And then you have a lower limit, okay, and then term start from term 2, because the u is 2, and then upper limit is 8. Okay, okay, for example here, if you sum from the upper to the lower, and then we have a formula of sequence. 2 multiplied by 2, 4, 6, 8, 10. We got the total is 28. Okay, so far do we have any question? Okay, okay, and then for the summation, if we can see here, if we want to express the summation for the first 1,000 term in sequence, for example, if you have J2 as the formula, formula of the sequence, we can see it's very hard. It's very hard to sum up all of the summation. So if we can see for solve this problem, okay, okay, we need to sum from 1 until 1,000. Okay, if you have the summation like this. Okay, so we generate the simple calculation or formula. Okay, that founded by the Carl Friedrich Gauss in 1980s. Okay, came out with the formula that from the upper limit, we go by the n plus 1 divided by 2. When you have such formula, the result of any summation can be calculated much more easily. For example, if you have 100 here, okay, the total of 100 from 1, we have n plus 1 divided by 2, n is 100, is equal to 50, 50. This one is total up based on the formula. Okay, and this one is another example. If you have, for example, we have 80 here, we have k equal to 1, and then the formula is k. Okay, we start from 1, then n plus 1 divided by 2. What is n? N is the upper limit. 80, 80 plus 1 divided by 2. And then we got 80 multiplied by 81 divided by 2. Okay, we got 3240. Okay, next one is if you have the formula. Uh, okay, formula, for example, k a power of 2. Okay, what you need is n plus 1 multiplied by 2n plus 1. Okay, you got 50 multiplied by 51 multiplied by 101 divided by 6. Okay, and then you got 42,925. Okay, this one divide by 4. Okay, and then this one is the formula lah. If you have the upper limit here, okay, and then we have kn for the upper limit, and then divide by 2 lah. Okay, and then if you have n upper limit, k power of 2, and then you should divide by 6. Okay, and then the power of 3, this one is formula divide by 4, and so on. Okay, for example, we have for some 100, k power of 2, k 50 is k is not equal to 1, and then we divide it by 6. Okay, then the total will be 297,925. Okay, this one is okay. If you have 50, you divide total 50 by 49. Okay, this one for the exercise. Again, this one in power 2 plus 1 divide by 4. Okay, we have 48 minus 47. Okay. Okay, and then the total will be 121 million. 272,334. This one is if you have a k, x power of k is equal to 1 divided by 1 uh, minus x. Okay, like this. Okay, and then we have 0. Okay, this one, okay, if you have outer and the inner, if you have the multiple, okay, multiple. Okay,